Okay, so I'll be starting right now. I was saying we had 4 minutes, but I think we have quite a number here. So in order not to waste much of our time, we'll be starting today's lesson. Let me share my screen. I believe you can see my screen now, I believe. Okay, okay. So we'll be starting right away. And yeah. Okay, so today's lesson we'll be looking at physics, and we'll be trying to do the same thing because I know we are close to exams, and I think it's next week Monday that UP's exam will be starting. So many people will have tried reading. So what we are trying to do is just trying to help cement what you probably tried learning, or probably draw your attention to what your mind might have not gone to. So that's what we're trying to do in today's lesson. And welcome. So as usual, as is normally how I start, I would always try to bring your mind not to stop, or I'll try to calm your mind down to help you know that it's not something to be scared about. Physics, yes, it can feel scary. It's one of the subjects that has many formulas. And to me, one thing I would say is, aside the English part of physics, the fact that it is using formulas is what makes it even much easier, because the main thing is just, okay, what formula am I supposed to use it? Then how do I use this formula? When do I use this formula? So aside the English part, to know some other cases involved in physics, it's actually very simple. It's just more as it's just kind of like maths in a way. But now it's even much simpler than maths because it's not really as curvy or really tricky as mathematics. So let's um let's start the lesson properly. So as I said, we'll be trying to shrink. We have twice this amount of lesson in the syllabus. If you check your notes on physics in the app, you should be having around times two of this. That's around 34 notes. But we'll be trying to shrink the entire curriculum to see how we can speed up to achieve 17 of these topics so that we can do half of the entire syllabus. So anyway, shift this here. So we're starting with physical quantities. So this is a part of physics that I can say is the beginning. And normally people don't really know something. Or I would say before, at the point, I did not really know why this portion was important in chemistry while I was in school. But from deep learning and trying to link things up, it started making sense. And that's what I'm trying to do now. So as is usually my style, I like creating a storyline throughout the entire courses, like throughout the entire topics we'll be treating. So our storyline today is going to be trying to see how, okay, not really how we can, but a way that robbers can, let me not say what should probably be flagged as bad. So we'll be seeing how physics could be used to aid a kind of heist. If you watch the movie Money Heist, you'll be able to know what I'm talking about. The heist is kind of like a bank robbery. So we'll be using that kind of scenario as our study case for this lesson. So we'll step into a bank, but first off, you need the blueprints, and you cannot just assume that, okay, you want to rob a bank. You not just assume that you want to rob a bank and just wake up, or robbers don't just assume that they want to rob a bank and just let me not use the word robbers. I don't really know where this video will be going to, but I'm not trying to encourage thief. Oh. Remember, as they are saying currently, now is not the time to steal again in Nigeria. So don't think of it. So I'm just using this as an analogy to try to call it or bring our mind to where these things will apply. So um, when you're trying to go for an operation like this, they actually need a physicist within their midst, someone that knows the numbers, someone that knows someone that knows how to be meticulous with numbers. So that's where physical quantities come in. So physical quantities are just a measure that are used to um, remember or calculate stuff, or to just a measure is a kind of measure. There are quantities that try to help measure different parameters. There are quantities that try to measure different parameters, and the key quantities or the main physical quantities are mass, length, and time. I think this one should be something that everybody knows here. We have few days to so I believe somehow you should know about it. So mass, length, and time, they are the key quantities or the fundamental quantities that we have in physics: mass, length, and time. Mass, length, and time. So now, how does this thing apply to a robbery case? If you want a case, an
Okay.
operation.
So this
Sorry, someone's mic is turned on. Let me see. Okay, thank you. So how does this apply to this our case? So we'll see how this would these quantities can be useful to a money heist or to a bank heist. So when I'll be using the word heist, for people that probably are not really much grammatical, just know that heist is just another word for robbery. So um, quantities like derived quantities are also used, and also fundamental quantities are also used. So how the case now, the story we are trying to build now is these robbers, they are trying to rob a bank, and their plan is to follow underground tunnel to dig into the bank or the bank's vault. Then once they dug into the bank's vault, they will then escape. So, but let's see how the story will play out. So if they don't have these quantities, or they don't have someone that has an idea of how quantities are or how they can be used, they will probably dig the wrong tunnel to the wrong direction. So with the knowledge of these quantities, they can be able to measure exactly where the bank is. Just imagine you want to dig underground, you can't see what is above except you've actually measured. So those measurements are these quantities, length. So they are these quantities, length. So this is how they come in, and even the density of the ground can help you be able to know what. And there are just different ways you could apply this though. So, but I'm just trying to bring in starting with just quantities. So now, let's assume they wanted to dig a, a tunnel that's going to be, say, 500 kilometers, no, 500 meters long. Imagine they want to dig that kind of tunnel, 500 meters long, and the person that is supposed to dig it is a dumb person or does not really have an idea of the difference between meters and kilometers. And then say, okay, they say we should dig 500 something long. Okay, no, wala, start digging in kilometers. They said in meters, the person started digging in 500 kilometers. What would happen is the person would end up digging a tunnel that would not land at the exact spot. So let's assume the bank from their entry point to the where they're digging their tunnel, the bank's location is, let's say, 500 meters away from where they are. If they don't know how to convert these units, or the person that is digging it is not a physics person, he might start digging maybe 500 kilometers, and 500 kilometers is way, way, way longer than 500 meters. It will delay them in terms of time, and will delay them in terms of accuracy, because now they'll not be able to get to where they're supposed to get to. Probably the tunnel will be dug and probably come out in a church. Probably come out in a church. So it's important that we should take note of this thing. This particular function of unit conversion is very, very important. So if there's one thing that you should take note of here from what I've been saying so far, take note that they said that I'm saying unit conversion is very important in physics. I cannot hammer on this enough. It is very important in physics. Why? Because most parameters in physics, most of all these constants in physics, they are usually given in SI units. They are usually given in SI units. So if you don't use them, if you don't convert them from wherever units they are to SI units, you will definitely get the wrong answer. And funnily, I don't know why these physics people that set the exam, they are that wicked, but they will give you that same answer that is wrong in your option. They'll give you the exact wrong answer in your option, and you think you're correct. I saw it was in the option. But when you now look, you find out that you just made an error just because of conversion. So conversion is very important. Sorry. If you're writing down, just take it that the first thing you always do when you see a calculation question is to confirm that the units, all the units are in SI units. Anyone that is not in SI units, first off, before you do anything at all, convert it to SI units. So what are SI units? SI units are those units that are in kilogram, meter, seconds. I think these are the basic ones: kilogram, meter, and seconds. Meter for mass, length, and time. Wherever they give you time in hour, just convert it to seconds to avoid stress. If they give you length in kilometers, convert it to meters. If they give you mass in gram, convert it to kilogram. I'm saying this because it's very important. This is the one reason that can make people fail for no reason. It's not really that you don't know the solving, it's not really that you don't know what you're doing, but just this slight error can make you fail like hugely, because the examiners will also help you fail if you don't do this particular thing right. So put it as a rule of thumb in your mind. Before I start any question at all, the first thing I would always do is to convert my units from wherever units they are to SI units. So that's by the way. So now let's move to our next slide, dimensional analysis. So this thing we just talked about, where we're trying to convert units to the right way or to the right position where it's supposed to be, is more like another aspect of dimensional analysis. But the main aspect of dimensional analysis that is being mentioned here is where you are trying to be ensuring that a particular formula is correct. So this portion of physics, I don't really know why they brought it up, but I think maybe if you are someone that is going to be creating theories, it will be useful to you. But normally, in simple terms, dimensional analysis, that is just trying to be ensuring that when you have a formula, be sure that the total units, when you solve what is on the left-hand side, the units you get at the end, if you solve the right-hand side also, the units you get at the end will be exactly the same. So if you solve the left-hand side and you get kilometers per second, if you solve the right-hand side, you must get kilometers per second. If you don't get that, something is wrong. So there are ways that this kind of thing comes out in your exam. How it comes out is that they will give you a formula. We'll see an example of how it comes out. They'll give you a formula and they'll tell you, check whether this dimension or this formula obeys the principle of dimensional analysis, or whether it is correct dimensionally. So what you will then do is you take the left-hand side, forget the right-hand side of equals to. What I mean by left-hand side is you have a formula, maybe ABC is equal to XYZ. So you forget ABC, take XYZ, and find the units of every single thing in XYZ. Then once you found the units, try to cancel out only the units, leave the number, leave the letter that is there. It is whatever it is, just leave the letters, just bring out only the units. Once you've taken out only the units, you will then start canceling out to see where you can get to that you cannot cancel again. That is the answer for the left-hand side. Then that same thing you do on the left-hand side, it goes to the right-hand side and do exactly the same thing. You forget the left-hand side. You will focus on now A, B, C. Bring out all their units. Bring out the units for A, bring out the units for B, bring out the units for C. Then try to cancel out as much as you can cancel out. And if you get the exact same answer, then you are correct. But now, it's not just as simple as it seems. There are two things you should take note. The next thing you should take note on in doing this stuff is plus and minus. Plus and minus. When there is a plus, you cannot cancel out. When there is a plus between two units or two parameters, you cannot cancel them out. Let me just take an example. Let's say we have, just on your book, you could just write, because I don't have a pen to write this here. But let's assume we have A plus B plus C is equal to X plus Y. What it means is that A plus B, A's unit must be exactly the same thing as B's unit, because what is separating A and B is plus. What's separating B and C is plus. So when plus or minus are separating two units or two parameters, their units must be the same for it to be correct. If one of them units is maybe in seconds and the other one is in meters, something is wrong with that formula. Something is wrong with that formula, so it must be the same. So if you have something like A equals to B plus C, it means that B, the unit of B, must be exactly the same as the unit of C. You get it? I don't know if anybody is confused at this point. If you are confused, just raise up your hand or ask a question so that I will know what I'm doing. Is anybody confused?
Yes, sir. Can you come again?
Okay, I'm coming. Let me see how I could do this now. Let me see. I'm trying to see if I can get the marker board here. This one, the marker board here. Okay. I am trying to find a marker board, but I'm not really seeing one here. It's supposed to be one here, the two, that is the marker two. It's not here. But the idea here is we are trying. What I was explaining was this now. I was saying when you have A plus B equals to C plus D. When you have, can everybody hear me? Okay. So when you have A plus B equals to B plus C, just take it in your head that the unit for A must be equal to the unit for B. Just take it in your head like that. When you see plus in units or in a particular this kind of question of dimensional analysis, just know that every of those ones that are separated by plus must be the same. So now, if you have A plus BC, A plus BC, it means the unit for A must be equal to the total unit of B and C together. B and C together, you can multiply them, you can cancel out what they have because they are joined together by multiplication. Even if it's division, you can join them together, you can cancel out. But once it's plus or minus that is separating both of them, their units should not cancel out. And what is on one side of the plus must be the same as what's on the other side of the plus. I don't know if I'm communicating. Someone's hand is up. I think Adijat or Obayomi. Your hand is up. I don't know if you have a question. Okay, probably your hand is up and you're not aware of it. So, as I was saying, when you have plus and minus, just don't let it confuse you. Once you see something like maybe something plus another thing plus another thing, it means that all those things that are separated by plus or minus, they have exactly the same unit. They should have exactly the same unit. That's what makes it correct. If they don't, something is wrong. So let's just move forward. When we get to the example, you will see how we solve it. So before we go to the example now, I was then saying, I said, in this our case for the robbery, things that will come into play are things like vector. If you want to escape or you want to drive or something like that, you need to know the direction you're driving in. And when you're trying to tell the driver driving so direction, take a left, take a right. That idea of telling somebody go with so speed to the left, take this speed to the left, take this speed to the right. By giving direction, you are introducing what they call vectors. But you're saying just increase your speed without mentioning the direction. You're talking about scalar quantities. So I think this particular one should be something that everybody should know. Scalar quantities are quantities that have magnitude but no direction. So just the simple thing, the difference between them is just once you are mentioning a direction to which one of them is following, just know that you're talking about a vector. So if they say something is acting downwards is already a direction. So gravity is acting downwards. So definitely, because we know that gravity is acting downward, you are already hearing a direction. Gravity is a scalar quantity. Speed. If you hear speed now, what direction comes to your mind when you hear speed? There is, by itself, speed does not have a direction. It's only when you say increase your speed forward or increase your speed backward, that's when you can know that okay, this speed is a forward speed or a backward speed. But when you're not including a direction, say forward or backward, that speed's name automatically, because you're adding direction to it, is no longer going to be called speed. It's going to then be called velocity. Because when you introduce direction to speed, it shifts from becoming just speed to becoming velocity. So that is the reason why sometimes you see people say, or you see them saying in maybe sometimes they'll say the velocity of something, speed of something. Both of them they have the same units, speed and velocity. They are just the same thing. The only difference is that speed His head is correct. Speed, his head is not correct, but velocity, his head is correct. Velocity has direction, while the other one does not have direction. Yetunde Rasak, I don't know, your mic is on. Do you want to say something? Or do you have a question? Yetunde Rasak, I don't know, your mic is okay. Probably it was a mistake. So now, there is now something that I think everybody should take note of. This one is one subtle question that can come out where they would ask you, find X component of a particular force or the Y component of a particular force. Just force is one particular parameter that has several formula. If you are someone that knows physics or you have been familiar with physics, you hear that force has a formula. Force is in magnetism, it has its own formula. Force is in gravitational force, it has its own formula. Force is in kinetics, it has its own formula. Force is in friction, it has different formula. So force now is one of the parameters in physics generally that if alone you can write all the formulas that it has, you would have covered a lot of things. Just taking force out and writing all the formula that is equal to, you will see that you would have a lot of links where force is applied or where how force can be. Just by that alone, when you say, okay, what are all the force formulas? You can just do that and maybe your ChatGPT or somewhere. Just say, what are all the formulas that are in physics or in 100 level physics? What are all the topics that have force and what are the expressions for force? You will see the expression for force in centripetal force. See the expression for force in just in any of the fields of physics. So force now, there is also what they call the components or the x and y component of force. So when you are getting the x component of force, it means when you're trying to resolve a particular force in just a horizontal direction, when you're trying to look at the force in horizontal direction, when you're asked to find the y component of a particular force, you're trying to look at the force in a vertical direction. So when you're looking at it vertically, force vertically, you're talking about the y component. When you're looking at force horizontally, you're talking about the x component. So all these things in normal sense, sometimes I feel they are unnecessary, but we just have to know these things. We just have to know it. It makes sense, but sometimes to me it feels stressful, but we just have to know it. So now, for getting the x component of force, it's just simple. Fx is equal to force times cos theta. But the y component of force is going to be of f sine theta. Once you just change fx is equal to f cos theta. Fy is equal to f sine theta. Fx is equal to f cos theta, and that is the horizontal component. Fy is equal to sine theta. That's Fy is equal to f sine theta, I mean. So that's for the vertical component. So just if you're writing formulas now, you can just be writing your formulas one after the other. And the first one is this one that I'm mentioning out now. So f is equal to fx is equal to f cos theta, fy is equal to f sine theta. So now this is what I was trying to explain here. So this is it here for the horizontal components. We have this where f represents the main force, theta represents the angle to the horizontal, and the same thing here. F cos theta, F sin theta, this for vertical components, horizontal components. So we mentioned speed. Speed also has its formula, and the formula for speed is distance over time. Distance over time. I think this one is common knowledge already. So I'm just trying not to waste so much time, but speed is distance over time. Velocity, on the other hand, is displacement over time. The simple difference between speed and velocity is just that one of them has a direction, the other one does not have a direction. They are the same, they have the same units. But the only difference is that one of them has a direction at which it acts towards, while the other one does not. So just take note of these formulas now. These formulas here, write them down. So now let's go to our first example here. So these are example questions that I'm taking from your exact GPEB exam.
Excuse
So
me.
we have this formula now. The formula is saying which of the following equation is not dimensionally consistent. So this, we are talking about dimensional analysis, what we talk about here. So this is where we'll be seeing how it plays out. So now this is an example of dimensional analysis question. So they're asking us which of the following equation is not dimensionally consistent. So now this is V, and I said the first thing you'd always do when you have this kind of stuff for dimensional analysis is to know that the left hand side must have the unit of the left hand side must be equal to the unit on the right hand side. So now looking at this here, the unit of, let's start with option A, the unit of V here is velocity, that is meters per second. So you can just start with left hand side is equal to V, and V, the unit of V is meters per second. Just know that that's for your left hand side. So it means that everything here must be equal to meters per second. So now we'll now focus on now this side now. So now this one, now these two of them here, they are separated by plus. So I said this one must be equal to this one. And both of them, if this one is equal to this one, that means they must also be equal to this one here. And normally we know that someone is not seeing my screen. Can you see my screen now? Can anybody see my can everybody see my screen?
Yes.
Okay. Okay. So we have this here, V. So U now is for initial velocity, still velocity. So we know that U is meters per second. So because U here is meter per second, it already tells you that true, this formula is correct because V is meter per second and U is meter per second. So these two are already showing that they are correct. So now let's check whether this one is also correct. This one is AT. A is acceleration times time. So these two, they can cancel out because they are joined together by multiplication. So acceleration is meters per second square. That is m all over s times s. That is meters per second square. M all over s times s. Then time is now s. That is times another s. So the s that is up would cancel one of the s that is down, and you now be left with m all over s. And that is already the same meter per second that this one is. This one is meter per second. So meter per second. And this one, the sum of this one is still meter per second. So because it is the same meter per second, it means that this formula is dimensionally correct. So if you do the same thing here, distance is in meter. It means that whatsoever you do here must be equal to meter. And whatsoever you do here, it must be equal to meter. But remember, I told you that you are not going to look at whatsoever number is there, just only the letters and their powers. T now has a power of 2, so it is important. 1 over 2 is not important because this 1 over 2 is a normal constant, so it is negligible. Only powers are important. Normal numbers are unimportant. They are not important. So even if you have maybe like 2 ut, that 2 is not useful. It's only if it is as a power that it's going to be useful. If it's not as a power, just know that it's useless. So the rule now is how, or would I say, if I want to simplify it, it means that when you see plus, you can just put an equal to. So if we have B equals to U, plus can be seen as another equal to on this end here. So you can say that this one must be equal to this one. So U must be equal to T. The same thing we're having here now. UT must be equal to whatsoever is here. So if you should do your dimensional analysis, you have meters per second for U times T, which is seconds. So M over S for U times S for T. So S for T will cancel out the S under the M, making you have only M. And we said that S is in M. So because this one, the entire summary of this one is going to be M, we can say that this one is equal to this one. So this particular two are first correct. So if you do the same thing here, you would also get the same thing. Acceleration is meters over S squared times T is S squared times S squared. So S squared will cancel S squared under, and you'll be left with only M. So now we have only M here. We have only M here, and we have only M here. So this is also correct. If we now come here now, we have velocity. Velocity is in meters per second. But now we have squared on this now. So that meters per second, you put it into brackets and put squared, meaning that everything inside that bracket would have squared. So we have M squared over S squared. I wish I had a pen. I wish I had a pen too. I would have liked to show what I'm trying to explain. But V is M over S. But now V has squared. So because V has squared, it means everything inside that V must have squared. So since v is m over s, it means that m will have squared, s will have squared. So it's now going to be m squared over s squared. That's what is here. So it means that this thing here must also be equal to m squared over s squared. And obviously, it's already that u is meters per second. And if you square it, it will also give you m squared over s squared. So this is correct. This is correct. So now this one now here, we have 2as. Remember, I told you, anyone that is not a power is negligible. Cancel it out. So we'll cancel this one out. When we cancel this one out, we'll be left with what they call it. If we cancel 2 out, we'll just be left, we'll remove it. We don't even need to cancel it, we just need to ignore it. So here we have a s. So v squared equals u squared plus 2s. So a is what? A is meters per second squared. So if a is meters per second squared, I think there's even an error here. If you're looking at this now, you see that there's an error in this. It's looking like as if there's an error here. We have m over s, that is m squared over s squared. Here we have m over s squared times s for, okay, this m, sorry, I was seeing this as t. So this is s is distance. S is distance, so there's no error here. So we have m over s squared times m. S is measured in meters. So that m in s will multiply the m in acceleration. You will now be having m squared over s squared. So all of them here are equal. So this is also correct. So normally, if I'm the one that is solving by myself, I've checked number A is correct, B is correct, C is correct. For the sake of time, I know that this one is going to be the correct answer. Since we're looking for the one that is not dimensionally correct, so this one will be the right answer. So let's see how it is truly not the right answer. F is for force, and force, if you know what force is, the formula for force is kilogram meters per second squared. Kilogram meters per second squared. So some people might ask, how did I know about this? These are the things that I think are the first things you need to memorize. Someone is saying they can't see my screen. Can any other person, can other people see my screen? Okay, if you can't see my screen, probably your network is lagging, because I think other people are seeing my screen. So as I was saying here, we have force. And before I move on, I said the things you need to know their formulas offhand. Offhand is the unit for velocity, unit for meter, unit for acceleration, unit for force, unit for power, unit for energy, units for pressure. So all these things I'm mentioning now, they are things that you need to know their units offhand, especially their SI units, because it would help you to move forward. It will help you when you're moving forward, when you're trying to balance formulas. Don't know that we know that force is equal to Newton normally, but don't take that Newton alone. Get the deep, that is the core SI value. That is that kilogram meters per second squared. So it's important that you take note of this thing. Note, if you can write down these things I'm mentioning. The parameters you need to know their units are distance. The unit for distance is m. The next one after distance is area. If you can't see my screen, just try logging out. I think my screen is, your network might be the one that is having the issue. So as I was saying, just log out and come in again. What is on my screen is just, I'm not showing anything on my screen. If you can see my mouse is showing where I am on the screen. So I'm not really, what I'm saying is not on the screen. What I'm saying is not on the screen. I'm just dictating what I think is what I think is important. So acceleration, the formula for the units for, we'll start as I was saying again from the beginning. The units you need to know is, you need to know the units for distance. Distance is in meter. So you can just write distance equals to meter. Know it offhand. The next unit you need to know is area. The unit for area is in meters square. Know it offhand. The next one you need to know is volume. The unit for volume is meters cubed. Know it offhand. These are the first three. Then the next one you will now be going to now is velocity. The unit for velocity is meters over second. Know it offhand. Once you've known velocity, the next thing you need to know now is acceleration. The unit for
Please
acceleration is
repeat the one for velocity.
velocity is meters over second. So whether it is initial velocity, whether it is final velocity, whatsoever thing that the name is velocity, the unit is always, especially for normal, for linear, this thing, it's always meters per second. Meters per second. After velocity, the next one is acceleration. The unit for acceleration is meters over second squared. Meters over s raised power 2. M over s raised power 2. That is for acceleration. I think this thing is something that many people might have already known, but sometimes you might forget it. So I would always say, if you know this thing off your offhand, it will help you later in getting units or balancing formulas to know whether you are correct or not. So after knowing acceleration, the next thing you then need to know is down acceleration. When you differentiate acceleration, what do you get? The next one you then need to know is now energy or force. Let me start with force. The next one after acceleration is force. Force. The unit for force now, we've looked at velocity, we've looked at acceleration. Then the next thing you should look at now is force. The unit for force now is kilogram kgm all over s raised power 2. Kgm all over s raised power 2. Kgm all over s raised power 2. That's for force. Then now, after force, the next one I will follow now is energy. So energy and force, they are similar. Energy and force are similar, but there is only one difference between energy and force. And the one difference between energy and force is that it is kgm raised power 2 all over s raised power 2. So energy and force, the difference is that energy, the m in force has squared. Kgm raised power 2 all over s raised power 2. That's energy. Kgm raised power 2 all over s raised power 2. Then after energy, the next one that follows now is power. Power. So power and energy, they look alike, very, very much alike. Power and energy look very much alike. But just that the only difference now. Okay. I'm coming. Maybe someone that has been listening should just probably help us type it in the comment box. So now, or maybe I would find a way to mention it again, but let me just not lose my train of thought now. So after energy now, the next one that follows energy is power. So after in power and energy, they look alike in their units. Energy is kgm raised power 2 all over s raised power 2. But now, sorry, energy is kgm raised power 2 all over s raised power 2. But now power is kgm raised power 2, the same thing as energy. But under now, instead of s raised power 2 like in energy, for power, s is raised power 3. S is raised power 3. So you see that from force to energy to power, if you look at these three things are seeming alike, if you listen to them, you're using force, you're using energy, you're using power. People in Nigeria would always think that maybe there are no difference because both of them, all of them, they are similar somehow. So even in their formula, also there is a similarity that you can trace. For force, it's just kgm all over s. Kgm what am I saying? Kgm all over s raised power 2. That's for force. Force is kgm all over s raised power 2. Force. For energy, it is kgm raised power 2 all over s raised power 2. For power, it is now kgm raised power 2 s raised power 3. So these are things that I put on my head. Like since I put them in my head, this way I'm arranging them for you guys. Starting from distance, going down till this point, you will start seeing the way they flow. It's not something that you need to cram. Once you can just understand how they are varying, you will be able to understand that okay, they are similar. For velocity and acceleration, when if you wrote down what I said about velocity and acceleration, they are very similar. So that velocity is m all over s. That is for velocity. But for acceleration, it's just the same m all over s, but now the s has raised power 2. That's acceleration. So velocity and acceleration, they are very similar. Velocity, acceleration, they are very similar. Energy, force and power, they are very similar, or force, energy, and power, they are very similar. So just take note of these things. So with these similarities, knowing how they look alike or how they are close to themselves, you might not really need to cram their units if you just understand how they look alike. So after that one, the next one you start looking at is now pressure. Pressure now is the next one you look at. So pressure now, on the other hand, now is now kgm. Pressure is over this thing. Kg force. Sorry, pressure is kg all over ms raised power 2. I did not group pressure with the other one because pressure is a little bit different. So pressure is a separate line, but pressure is similar to all these force, energy, and power. If you look at them, they are always similar things that have to do with similar power something. Force is a powerful something. Energy is a powerful something. Power is a powerful something. But pressure also is a kind of powerful stuff, but it's not exactly among that their league. So it's similar to them, but there's a kind of small twist to it. So pressure, it is kg all over ms raised power 2. Kg all over ms raised power 2. Kg all over ms raised power 2. So I would say these particular things I mentioned now, they are important that you just know them at the back of your head, because most formulas moving forward are just a mixture of these things. Most formulas moving forward are just a mixture of these things. Most formulas moving forward are just a mixture of these things. If you should look at the formula for, just think of it, any formula, most formulas you look forward, they are always a mixture of these things. But just take them down by as the things you just need to know, especially for this topic of dimensional analysis. Dimensional analysis and the first portions of kinematics, that is physics. So now the answer for this one is obviously this D is the answer. So the reason why is because here force is in meters. If you have your book, you have force is kg m all over s raised power 2. That is force. So now here we have m is kg, v is meters per second. So v is already m over s raised power 2. I don't know, is kg. This one is kg. V here, look at this thing I'm showing you down here now. This is it here. Kg is here. M over S is here, but now you put squared inside them. So it's now kg m squared over S squared. R again now is R is distance, is the thing that has to do with distance, that is radius. Radius is something that has to do with distance. So it is m squared. So alone, this R now has made the whole thing look flawed. If you should do the balancing of this, it will give you something that is not the same thing as kg ms raised power 2. So your answer will be incorrect. So that's why this one, normally I would not need to even solve. I'll just check, okay, this ones, I know this ones. And if you are a person that is very, very familiar with force or these equations of motion, you already know this formula is correct. This one is correct. This one is correct. So this one is one of the formulas, but something is wrong here with this squared here. So this one is the wrong answer here. So now let's go to another of the example that we have here. They said a vector of magnitude, this force, this is a force. So force, the value for force is kg ms, all of kg m over s raised power 2. That is the formula for force. So then now, another unit for force is Newton. Is in Newton. Force has another unit. Okay, yeah, I think it's important that you even mention this thing. So if you wrote down these things I was mentioning about force, energy, and power, if you wrote them down, after you've written that force is equal to kg m all over s raised power 2, in front of it, also write equals to Newton. That's equal to n. Equal to n. That's another unit for force. So then now, for energy now, energy also has its own. Energy now, that's kg m raised power 2 all over s raised power 2. It is also equal to J, that's joules. If you're writing, just also write joules, J. Power also has its own too. Power normally, the real SI unit is kg m raised power 2 all over s raised power 3. But now it is also equal to W. It's also equal to W. Okay, I would see what I can do. I think somebody is still asking for the formula. Maybe I would find a way to do this for this person, because I'll find a way to get you the formula. I'll find a way to get. Are you? If you're on the group, just type yes. If you're on the group, the WhatsApp group, just type yes. So I'll know that I can easily drop it there. So in case once the class is over, I can remember to drop it there. So then now, yeah, okay, thank God. So now here yeah, okay. So I'll drop it there. Okay. So now, as I was saying, no problem. I'll drop it on both groups. So as I was saying now, we have this formula here that says a vector of magnitude 50 Newton. From seeing the units, but there is this sheet I always use when I always see questions in physics. Then once I see the unit, I can use the units to get the formula that I can use to solve to get my final answer sometimes, but I cannot start explaining that particular one to you guys because it's only someone that is probably technical in maths that can be able to understand that particular pattern. But most of the times, physics questions can also give you the answer by itself. So we have a vector of magnitude this. This is a force. So whenever we are saying Newton, it's force. I think we saw Joule, it's energy. So a vector of this force acts at an angle of this. So we are already seeing force. We are already seeing angle. So which formula can we remember that has angle and force? Let's not just guess. The answer is find its x component. If you can remember when I said something about x component and y component, your mind should go back to that formula of s component. Formula for s component is fx is equal to f cos theta. So already I already you find fx. So fx is equal to f cos theta. Already you're not seeing that this is your f and this is your theta. So you can put it in the formula, and if we should solve it like that now, we know that f is 50, theta is 20. That's what they gave us. F 50, theta is this. So now, if we should remember the formula that I mentioned, fx is equal to f cos theta. So we already know that we're looking for fx. They say the x component, that's fx. So f is 50, theta is 120. So now we can put it inside here that this one is 50, this one is now cos 120, and we'll be having this as, this one is just a statement. So we'll be having this as 50 times cos 120. That's from this formula here. We have fx, which is our fx, is equal to f, our f here is 50, that's 50 here, times cos, we bring your cos down here. Theta is theta here, 120, 120 down here. Then if you should solve this to your calculator, you should be getting your final answer to be this. You should solving this one, you'll be having minus 0.5 here. That's this here. Then solving it further, you'll be having your final answer should be minus 25 Newton. So if you got minus 25 Newtons, then just know that you are correct. But if you did not get minus 25 Newtons, know that you made a mistake somewhere. So if you should stop, normally this pattern of solving where you take things one step at a time is usually the easiest way to solve stuff. The school I went to when I was in secondary school, that was how they taught us. They would always say, break it step by step. Once you do things one by one, even if it is 2 plus 2 plus 2 plus 2, if you should take it one by one, take 1, 2, 2 plus 2, 4. Write everything again, put that 4 down. Then after that, plus 2 plus 2 plus 2. Take another, it just take you time, but you will get your correct answer. So long as you take it step by step. So with all these steps now, we are able to see that our final answer is minus 25. But now calculator can just help us. We can just type this times cos 120. We'll get our answer straight as minus 25 Newton. So I hope that is clear for everybody. So now let's go to the next set of questions now. So we have another set of questions here. We have convert 72 kilometers per hour into meters per second. So this is what I was telling you. I said for every single question they give you, always convert it to SI unit. So the reason why I did not convert this one to SI unit here is because remember that this one is already in SI unit. Newton is the same thing as kilogram meters per second, so is kilogram meters per second squared. So this is force, the same thing as force. So it's already in the SI unit. So assuming it was in gram per meters per second, that gram supposed to be gram, supposed to be kilogram, so we would have converted. But since it is correct, we don't need to convert. So now here we are trying to convert from kilometers per hour to meters per second. So kilometer now is not an SI unit. Hour is not an SI unit. I said SI unit is For kilo, for mass, it is kg. For length, it is meters. For time, it is seconds. So now this one is, instead of meter, we have kilometer. Instead of hour, we have, instead of seconds, we have hour. So we need to change this thing. So normally, kilometers, kilometers, from meter to go upwards, where you know that you are multiplying. Meter, there is centimeter, there is millimeter, there is decimeter. Just know that millimeter, centimeter, decimeter, those ones are small, small values, are small. But now, if you go from decameter, I think there's another one in between. I think it's hectometer, then kilometer. Those ones are higher values. So these things I mentioned are just things that you should just take note of. If I had a chart, if I had a straight line and I wanted to arrange them, meter is in the middle. You want to know those that are smaller and those that are bigger. Meter, towards the right, we have decameter. There's a difference between decameter and decimeter. Decimeter is the smaller one of decameter. It's just 10 spaces away from meter. 10 lines away from meter is decimeter. Centimeter is 100 lines away from meter. Centimeter, cents, 50 cents. No, it's not 50. Don't take that as 50, but cents means 100, a century, cent. Centimeters, centimeters. That is, centimeters means cents. 100 smaller values of the meter. So centimeter is smaller than meter. Millimeters, million. That milli in not million, milli in holding, I think in a particular, is it in Roman numerals? Milli is supposed to represent 1,000. So centi is 100 units away from a meter. Deci, if you look at all those ones, they have I, centi, deci, milli. Those ones are the ones that are the smaller values. But this one, deca, that is the same 10 ways, 10 ahead of this, is bigger. You will not really see decameter most of the times. You will not really see hectameter most of the times. You mostly see kilometers. That is the one that they always learn to mostly in physics. So from centimeter, from meter, going upwards, you'll be going from meter to decameter to hectameter to kilometer and so on. Kilo, no, kilo is 1,000. They always say things like that. So I'm measuring this in now so you'll be able to see how these things are not just arbitrary. So when you have centimeter, you're trying to go from from the low side to the high side, you are dividing. If your value is from a low side to the high side, you are dividing. So if they gave you centimeter, just know that centimeter, centi is the smaller one. Centi is how many? 100 away from the meter. So you divide by 100. Millimeter, whatever they give you, millimeter, li, I, okay. So we are on the small side. Milli is 1,000 away from meter. Okay, so meaning we are dividing by 1,000. So, but if you are going away, like if you are going from higher value to a lower value, you are going to be multiplying. So now, kilo, we know is 1,000 away from meter. So we are going to be multiplying 1,000 by 72. I'm just trying to tell you this so you'll be able to understand how these values, you don't need to cram them. You don't need to cram them. Kilometer is 1,000 kilometers. 1,000 meters equals 1 kilometer, but that thing can be confusing sometimes. But if you learn it very well, you might be good for you. But if you don't understand it, just understand that this is how they arrive at it. 1,000 kilometers. When you're moving from big to small, you would have more. If you have $100, $100 is a big money. Moving from $100 to naira. Check out now. If you should move from $100 to naira, you have over 140,000 naira. So your value should be bigger when you're moving from big to small. Whatever you're getting should be bigger. When you're moving from small to big, it should be smaller. If you want to convert 140,000 naira to dollar, you'll be getting only $100. So it should be smaller. When you're moving from small to big, you'll be getting a smaller value. So this thing should help you give you a kind of mental perspective. When you're moving from small to big, you should be getting a smaller value. But when you're moving from big to small, you're getting a larger value. So to convert this now, 72 kilometers to meter is just by multiplying by 1,000. You get it. Then now you now have, do it one by one. Kilometers by multiply by 1,000. Then hour, changing from hour is you're moving from big hour to small. We know that 60 seconds make 1 minute, 60 minutes make 1 hour. So 60 times 60 will give us 3,600. But just put it in your mind that from hour to seconds is 3,600. 3,600 from hour to second. From minute to second is 60. From hour to second is 3,600. From day to second, you will multiply that 3,600 by 24. So you'll be seeing how it varies. So just know that from hours to second, because they will hardly put it in day most of the times, but from hours to second, just know that you'll be dividing by 3,600. So just know that since this one here is kilometer, kilo over meter, kilometer is 1,000, put it there. Hour, 3,600, put it there. So this is what I'm talking about here. Kilometer, 1,000 by this. So if you now multiply it now, if you multiply that 1,000 over 3,600, you'll be having, just doing this kilometer per hour, 1,000 over 3,600 will give you 5 over 16. So you can now multiply that 5 over 16 by your 52. You'll be able to get your real units. I know this thing seems a little bit long or somehow complicated, but I'm just trying to see how we can get the idea of the whole thing without needing to cram it. It's actually simple, but it can be tricky. My advice will always be that try to know some topics in physics very well, so that whenever they bring those topics, you can be sure that any question that comes from that particular topic, you will smash it. Then your issue will now be once you don't know, then that one will be on God. That one will be on God. Even if God was supposed to do a miracle in your mind, that maybe in the end you will not start thinking very fast or something will happen, you will not know the answer. Start with the ones you know. I would always advise anybody, start with what you know first in your exam. Don't start looking for, this one is hard. Jesus, this one is very hard. Hey, this one is very hard. Hey, well, always, when you start a question, just look at it. Is this one hard? Anyone you don't know, skip it, go to the next one. Skip it, go to the next one. That way, you are covering up ground. And if for any reason your mind starts rebooting and starts getting the answer correctly, you can come back to those ones and you see that you start remembering. I don't know how that thing happens, but it usually happens in exam where at the beginning you might just feel overwhelmed. But once you just find one you understand that you could solve, you will most likely find another one that you understand that you can solve. You get? So look for the simplest things. Just pick, like, if you can just understand between, if you can understand what I've taught you so far in physics, this thing that we talked about so far, you can understand them very well, know the formulas that are involved in these topics of velocity, acceleration, and this thing, and know how the questions come out, and tackle them very well. I can say you've taken 20% mark already. If you had 100%, you've already taken 20% to yourself. If you should know it and know it very well, you've already taken 20%. Then next, you now start going to another topic now that is grouped together. Memorize them together. And once you memorize them together, that should be your next good topic that you can tell that, okay, if I see this question on this topic, I know them. I see this question on this topic, I know them. That's why we grouped on the app. People that have the app, you know that they are grouped by topics. So once you can memorize how questions come out in a particular topic, solve them and solve them and solve them. Most times, I don't know Nigerian exam systems, they don't really know how to twist questions most of the times. It's only when you get to the university that they know how to twist it very well. But most times, if you can solve, say, 5 years span of the same topic, you will find out how they repeat. Either they will tweak numbers, or they will just tweak the question in a way, but it's still the same thing. The formulas are almost always the same. You're always going to use the same formula, but if you don't know, you will not know. So just take one. If you don't have the app, find someone that has the app around you, or get the app. Take one topic, solve as many questions as you can find in that topic. Probably just span it to like 4 or 5 years. See all the questions that are there. Look at how they solve them from 1 year to the next year, to the next year, to the next year. Once you are done with that particular topic, rest. Go and find something for yourself. And if maybe buy egg or buy anything at all, come back to that same particular topic, solve it again. You solved it before, but solve it again. Before you know, your mind will start building a kind of connection in your mind. Before you know, you start getting a question on your mind. And once you start getting that pattern in your mind, you find out that you might even see that they are even repeating questions. You might see, it most likely will happen that they will repeat the question. So just taking note of that kind of pattern. So I'm just mentioning this because I know physics can be a little bit tricky, but it's actually the simplest most of the times. So this question, this one, I did not solve this one. This one is just simple. It says scalar quantities can never have, they have magnitude. They don't have direction, so they can never have direction. They have units, they have decimal values, but they can never have direction. That's just it for that one. So the answer is just that they can never have direction. So let's see the next one now. So now we are now in another portion of this thing, and this portion is kinematics. So this is another portion of the whole thing now that it can be very, very, very simple. If you can understand kinematics very well, you can also take another chunk of the entire studies of the entire physics now. If you can understand those first portion that we just talked about now and understand kinematics and projectile, you know another strong portion of the exam. Even if you don't know everything, you might be able to know at least 30%. Then anyhow, do your 30% first. Then anyhow, your mind will be able to think about the remaining ones. Or you might even do your, if you don't find any way, you might just do read ABC to Z, and anywhere the thing land you, click down as the answer. ABC to Z, anywhere the thing land you, click the answer. So that's just by the way. So now talking about this kinematics, there are four formulas. There are three formulas for kinematics. So this is one of the simplest topics in physics, kinematics, where they would tell you something like this. Where they will give you a formula that you need to use either of these formulas. Let me see whether I have those formulas in front here. I should have them here. You know, they are in front. So these formulas, V equals U plus AT. This is the first formula for kinematics. V is equal to U plus AT. Memorize it. The second one is this one. Memorize it. S equals to UT plus half AT squared. Memorize it. The next one is B squared equals to U squared plus 2S. The reason why I'm memorizing this thing is because questions will definitely come out from these things. Definitely. If they tell me that I should close my eye and do like as if I'm a witch to guess questions that will come out, I can tell you that questions that we will use one of these three will definitely come out. Even this one too, definitely will come out. How will you know? Check questions where they give you units that are similar to these things. Any question that you see mass, kilogram, and acceleration, most likely is a force. You need to find force. When they give you mass and acceleration, you know you most likely need to find force. Sometimes they might want to step it a little bit down. They will give you mass and velocity with time. We already know that acceleration is velocity and time. So they're already telling you, once you're already seeing mass, your mind should be telling you what formulas have mass in it. So once you're seeing mass, your mind should already know that I most likely will not be using either of these formulas. I most likely will not be using either of these formulas. If you're talking about mass, you're going to be either looking at pressure, energy, power, or force. So whenever you see mass in a formula or in a question, you see them, they give you a kilogram or mass, just remove your mind from kinematics and just know that, okay, it's something that has to do with either force or energy or power. Force, energy, or power, or pressure. You get. So by this kind of thing that is now, you can be able to filter questions and know which formulas you'll be using. Let's just see an example here now. We have a formula now here. We have a question now. We are seeing that there is kilogram here. This question definitely would need something that has to do with either force, energy, power. That's one. This question does not have kilogram, meaning that we don't have anything to do with force in this question. So most likely we are doing with kinematics because we're not seeing force here. Because we're not seeing force, just know that your mind is going to be towards kinematics. We are seeing something that is related to velocity, meters per second, acceleration. We are dealing with kinematics. So with this kind of mindset like this, you can be able to start predicting what the formulas that you need in a question should be. So now let's go back to do some justice to this thing now. So this was where I was, and I was saying that there are formulas. For this formula now, I think the main thing I'm supposed to explain here about this thing is what all these parameters mean. Kinematics is just talking about the equations of motion in simple terms. I'm trying to even not use this story for the I think it will take a little bit of our time. But kinematics in general is just talking about equations of motion, and there are three equations of motion, which I showed you in front, and I'll still show you again. And those equations of motion, they have parameters. S represents distance. I don't know why they made it distance. They did not use D. Because sometimes that thing really confuse me. As this S, it might make me think that maybe it is speed, but it's not speed. It's D. S is distance. U is initial velocity. I don't know why they don't use I. I don't know why they don't use I, but that's their problem. Or maybe they will even use something like VI, who now is velocity initial. But they use U. Just know that U represents initial velocity. T is time. A is acceleration. So this is one of the equations of motion. Then now, if you then move forward now, we have the rest ones here. Let me go to those ones here. See them here. We have D equals to U plus AT. V is velocity, final velocity. U is the same initial velocity. A is acceleration. So when you are seeing something that has to do with velocity, just know that, okay, you're looking at kinematics. Kinematics, kinematics, kinematics. One of these ones will fall in. One of these formulas would help you. One of the formulas will help you. So now, what was I even saying? I was here. So as you have this, your VUA, just know what these parameters mean and know that initial velocity. I think this is another thing that confuses. When you hear initial velocity, the next thing that confuses you is that all those times they will say when your initial velocity is 0, when will you know that it is 0? When you know that it is that the final velocity is 0. So when they say a car starts from rest, or I think people that are used to solving, they already would know this. When they say a car starts from rest, already they're already giving you one of the parameter. They might not tell you the initial velocity is 0. They say a car starts from rest, so that you should know that the initial velocity is 0. So whenever something starts from rest at all, whenever you see rest, just check, is it starting from rest or coming to rest? If it's starting from rest, know that U is 0. If this comes to rest, it means that V is 0. If it says starts from rest, know that U is 0. If it says comes to rest, know that V is 0. So acceleration, if they say it is being thrown up, know that acceleration is going to be minus. If they say it is being dropped down, know that acceleration is going to be plus. But now, they don't even need to tell you the value of that acceleration when they say it is being dropped from a height. Acceleration is automatically going to be 10 or 9.8. Because when something is dropped from up down, the acceleration is constant. And the acceleration is that acceleration due to gravity. So once something is thrown up or dropped down, they don't need to tell you the value of the acceleration. They already told you that thing. When you see an object is being thrown up, just in your mind, know that that thing is acceleration. They've already told you acceleration already. So object being thrown up, it means the acceleration is, I'll be using just 10. It means the acceleration is minus 10 when it is thrown up. When an object is being thrown down, it means the acceleration is plus 10. So these are some of the tricky stuff that they will just mention that can be confusing. The tricks of velocities and the tricks of acceleration. So for the tricks of velocities, when they mention something about rest, check, is it starting from rest or is it coming to rest? If it starts from rest, you know that if it is starting from rest, know that U is 0. If it's coming to rest, know that V is 0. If they're talking about acceleration, if they say it is being thrown up, know that your acceleration is minus 10. They say it's being dropped down, your acceleration is plus 10. Put all these 4 things in your mind. Put all these 4 things in your mind because it will help you very well. Anywhere at all, any question they're telling you, thrown up, they're already giving you a hint that acceleration is 0. So then that is for that one. That's for kinematics. This thing I was trying to explain here. So the next thing here is now projectile. So projectile now is another part where it's still a portion under kinematics. But now it is not, kinematics is talking about motion in a straight line. Where you're either throwing something up, dropping something down, or shooting something forward. That is driving something forward or driving something backward. That is what it is. That is kinematics. But now when you come to projectile, it is now talking about when something is not just moving forward straight or going upward straight, it's going in a curved path. When something is moving in a curved path, you're talking about projectile. When something is moving in a coiled path, you're talking about projectiles. So it is still about motion, but now it is just different. When it's moving in a coiled path, it is projectile. So now, Projectile has formulas also. It has formulas also. And the formulas now are, I think I did not write them here. But the formulas for projectile, the first one is time of flight. Memorize them. There are also three. We know that we said the equations of motion, there are three. So for projectiles also, there are also three main formulas for projectiles. The first one is for time of flight. Time of flight. And the formula for time of flight is equal to 2u sine theta over g. 2u sine theta over g. 2u sine theta over g. That's for time of flight. The one for the next formula under projectile is now maximum height. Maximum height. The formula is now u square sine square theta all over 2g. That is u raised to power 2 sin raised to power 2 theta all over 2g. That's for maximum height. So what you need to look at, I'm mostly talking about formulas in this physics now, because as I said, formulas most of the times they can be a hint to tell you what you are talking about. So when you are seeing that you're talking about how you know that the question is about projectile is when they're talking about they're asking you something like, what is the range? What is the maximum height? What is the time of flight? Sorry. And they are mentioning degrees or angle. Just know that they're not talking about regular time kinematics. So if you remember, I said kinematics when they don't mention kilogram, they're talking about kinematics. When you don't mention kilogram, they most likely will be talking about kinematics. Most likely will be talking about kinematics. So now, it's not only kinematics that they will be most likely talking about. They can also be talking about projectile. So we can say kinematics or projectile. So now, for projectile, how do you know whether it is under kinematics or it's under projectile is when you start seeing angle and you don't see kilogram, you start seeing angle, they're most likely talking about projectile. You start seeing something that they're mentioning range, they're definitely talking about projectile. You start talking about time of flight, they're definitely talking about projectile. You hear maximum height, they're most likely talking about projectiles. So now, the next thing you should now do, because of they're trying to be wise, is because you should then know the formulas for these things. So if you're asking for time of flight, you should know that the formula for time of flight is 2u sine theta over g. If you're talking about maximum height, the formula is u squared sine squared theta over 2g. If you're not talking about range, the range is the formula for range. The formula for range is now u squared sine 2 theta. U squared sine 2 theta over g. U squared sine 2 theta over g. U squared sine 2 theta over g. So that's the formula for range. So there's a way I usually use to memorize these formulas, but I don't know whether we have that time for me to show you how to do it. But if you look at all the formulas, all these formulas, they have u sine theta over g. All the formulas, these three formulas, they have u sine theta over g. So now, so you will not cram it. Time of flight is the one that starts with 2. And the one that starts with 2 does not have 2 in any other place. Time of flight is the one that starts with 2. T for TWO2. Time of flight is the one that starts with 2 on the formula side. And that 2 is only in U. It does not appear in any other place. It's not in sine theta. It's not in G. But now, when you're talking about now, maximum height. Maximum height is the one that G is under. That 2 is under, I mean. Maximum height is talking about going up, but it's ironically 2 is now under. The 2 you're talking, there's always 2 in these formulas. The 2 now in this case now is under. You're talking about height going up, but now it's under. So just take that, okay, maximum height in the one that has to do with height, the big 2 is under, and that big 2 is beside G. But now, other ones up also have 2. Unlike time of flight, other ones have 2. But now their 2 is not big 2, it's now raised power, raised power. So U has raised power, sine theta has raised power. That is sine raised power 2 theta. So then for now, range is now the one that has to do with where theta is now. The range is where the 2 is with theta. Range is where the 2 is with theta. Range is where the 2 is with theta. So range is where the 2 is with theta. That is the one that I cannot link to anything, but just now, once you can remember time of flight is the one that 2 starts on the top, and there is no 2 any other place. Maximum height is one that height is going up, but now the 2 is going to be under, and other ones up has 2, but the 2 is not big 2, it's small 2, has power of 2. So now maximum height and range now on the other hand now 2 is only with everybody up, but the main big 2 is with only theta. So meaning that U has raised power 2, then sine 2 has 2 theta. So you might easily be able to memorize it, or you might be able to use this pattern I'm trying to explain to you guys. I don't know which one of them you find easier to memorize, but just understand that there's actually a way the 2 has been moving. The 2 has been moving from one parameter to the next, like that. But there's sometimes that thing will move and it would not have, it's only one of them that will have 2. So just take that in mind, Sha. That's for projectile. So when they're asking you for the maximum height, you know the formula to use. You should know the formula to use. And the same other maximum height, you should also know that they say starts from rest because velocity is involved now. If they say starts from rest, or a ball is thrown from someone's hand, from rest, they will always mention from rest most of the times. They will most likely mention from rest. But in case they don't mention from rest, most likely it will be starting from rest most of the time. So you would be most likely 2. You most likely 0 in most cases. Then G in all these projectile something. They don't need to mention that G is something. Just know that G already is 10 or 9.8. So this projectile is very, very funny because almost everything that you need is always already given to you. It's almost always already given to you. You don't need this is a constant. U can be a constant as U equals 0 when it's starting from rest. G can be a constant. It's always a constant, not even can be. It's always a constant because it is 9.8 or 10. So if it's now thrown upwards, down is left for you. But most of the times, you don't need to be concerned about thrown upward or thrown downward for projectile because the formula caters for it. So that's for this now. So now let's go to collision now. So this now we're not talking about when we now go to force, collision, Newton's law. So it's now in Newton's law that you start seeing things that has to do with kilogram. Using Newton's law, you start seeing things that has to do with kilogram. From Newton's law, when you start saying kilogram, you know that the formulas of force, energy, power, they come into play. Pressure comes into play. Then one other thing that I did not mention, momentum comes into play. Force, energy, power, force, energy, power, pressure, and momentum, they come into play when you talk about Newton. And that's when you know that you're using either of these things, is when you are seeing kilogram in your formula or they're asking you about mass. So if you don't see kilogram in the formula, they'll most likely be telling you to find the mass. But if you see kilogram, then you should know that you're dealing with something that has to do with either force, energy, power, or this. It's just as it can be as tricky as that, and it can be as simple as that. It sounds simple, but just you'll be surprised that this can help you know or give you direction in your solving. So we have treated dimension them. Now we looked at kinematics them. Then now we are now looking at Newtons them. So this Newton's portion now, if you can only be able to handle, if you can be able to handle these first 3 portions that we're talking about, you'll be able to do a reasonable percentage of your exam, most likely the objective and even the theory. So except they do something silly, but I don't think they will do something silly. But most of the time, it's always like there's always a fraction of this your question that would always be within these topics. So now, for force, I already told you what force can be. Force can be very, very funny. It has different formulas depending on where it is being applied. But for Newton's, force is mass times acceleration. For Newton's law, force is mass times acceleration. It can have other expressions, but also that from force equals to mass acceleration, you can get other expressions. So long as you're talking about Newton. But just know that for this now, it is force equals to mass acceleration. So they are Newton's law, the first, second, and third law of Newton's laws of motion. So these Newton's laws of motion now, they have their formulas. They have their formulas, but just that one is just by the way. I think that all those memorization of laws, they are just by the way. They're not really core stuff, chat. They're not really core stuff, but I just feel the main thing is the main places that are the most difficult are usually these solvings. So what I'm trying to do now is trying to give you tips on knowing when to use which formula. So we still have another physics class. We still have another physics class coming forward. But what I want people to do is this knowledge I've told you, just go to your past question and just try to see whether your goal should first be, okay, this tutor said that we should just always check a question and check if we see kilogram, we know that it's within Newton's law. It's not going to be kinematics. If we not see kilogram, most of the times it's going to be in kinematics. So just use that and go and see how many questions in a year you can be able to mark out. You don't need to solve it, just mark out that, okay, true, this thing was actually true. This was actually true. Or even if you have the app, that our app, just check under kinematics how many questions did not have these things we talked about. I don't know if this is making sense. Just why I'm kind of seeming to round up here is because we are about rounding up. Where we'll be going to next is, at this point, I cannot go deep into gravitational force because these are not separate function of this whole thing. I know the examples would have gravitational force, but if I should want to go into the depth of gravitational force, we've not even explained this one very well. We've not explained this force very well. We've not explained momentum very well. There's elastic momentum, inelastic momentum. I know that they are just I need to do to these things for us to be able to truly say we've overcome these dynamics. We've looked at kinetics. We're not supposed to go into dynamics. That's the portion of Newton. But I cannot say we've done dynamics because I've not really gone deep into this. The next class, I will be preparing a different slide. I will expand more on this. So my aim now for this lesson is not to teach you every single thing because I know we don't have much time. But my aim is to teach you at least 50% so that you can be able to get something solid that you can work with and be confident with. So going back, the assignment I'll be giving you is go and check for your topics for these things we've looked at now so far, for dimension and motion, for dimensional analysis and SI units and unit conversion. Those three topics. Go and look at all the questions that are coming out in those topics for probably up to 5 years back for your physics studies. Look at all of them, focus on it, see how the questions are being twisted. You will start seeing patterns. Each year would always seem to have similar patterns. You always seem to have similar patterns. Once you're done with those ones, the next thing you then do is kinematics. Once you've gone to kinematics, you start seeing the same patterns in kinematics. When you don't see kinematics, they will most likely not have kilogram. And the formulas are usually going to be something that is solvable with these formulas we've mentioned so far. So then now when you then leave that one, the next thing you're not supposed to go into is projectiles. During my time, projectile was one of the topics I always wish to see because I know the formulas are just straightforward. They are all straightforward. They are just like straightforward questions. You would always know that it's a projectile question when you don't see kilogram. You would always know that it's a projectile question when you don't see kilogram. And when you start seeing degrees, that is angles, you are dealing with projectiles. You start seeing meter per seconds, meter per seconds, meter per seconds, angles, meter per seconds, that are dealing with projectiles. So that will be all for this particular lesson for today. I don't know if anybody has any question for now. I'm deliberately stopping here because of this year. I'm deliberately stopping here because of this. This is not as explained as it's supposed to be. I don't want to just make you feel that you've done this when you've not actually done this. So thank you all for today. If you have any question, you can raise up your hand, or you could just raise up your hand if you have any question. But for now, if you don't have any question, I'll be calling it a wrap. It's already 9:30. I have an engagement I need to meet up. I asked for permission that I'll be a little bit late by 9:35. So see you all in our next class. Our next class should be later this week. Good night, everybody.
My battery is low. The phone will just off. Like, if they teach you anything, I don't know. It's a man. I know you. Like, nothing else. Since that I should have been anybody. Actually, nice. I'm going for. Oh, yeah. Join meeting. Have you played join meeting? There's only two. No wonder. There's only two. Like they're finished. There's only one person and me that is there.
Every day about this girl. Jesus. My message is still there. Oga, shut up. Shut the fuck up.
Who dey talk to our oga like that oh?
I'm not doing it. Just say you know, give 10%.
Who is our good abi? Just to say anything. He is in the group. You never come online.
Uh-uh.
Why?
My message is to the
When last did you go online?
analysis.
This life. What's in this life? I swear. See fine girl now. See fine girl. Small but mighty dimmer. Okay, never. Milky chin chin. Oh, small thing. Ma just chat this girl, don't you? So status kind of a view. Interesting. What's that mean? Odnaka. Who are they call? Hey. Miss Oma. Look covered.
If you want fix now,
To her jacket.
oh,